Most series are too complicated to find a simple way to get an exact formula, like the geometric series. So we have a few tests to simply check whether the series converges or not. So each test is useful for certain kinds of series, and once we know that a series converges, other methods can be used to estimate its value. So the first test we're going to describe is called the divergence test. So first let me write down what the divergence test says. So the divergence test says that for a series, if we take the limit as k goes to infinity of the individual terms of the series, and we see that the limit doesn't go to 0, then the divergence test says that the series will diverge. Essentially, the meaning behind this is for a series to converge, the terms have to get smaller and smaller and smaller until they're negligible. Whereas if we have this case where the terms don't go to 0, then the terms don't get negligible, and then so the series has to diverge. So that's the divergence test. And in the case where the limit is equal to 0, then the series still may converge or may diverge. So the test is inconclusive, and so some other method has to be used. So this test only says something when the limit is not equal to 0. In that case, the series diverges. In the other case, the test doesn't say anything at all. Okay, so let's take a look at a few quick examples. Okay, so let's take a look at the series. The sum k equals 0 to infinity of 2k plus 1 over k plus 2. Okay, so we want to apply the divergence test. So we take the limit as k goes to infinity of the terms ak, right? So the terms ak is this formula here. So we take the limit as k goes to infinity of 2k plus 1 over k plus 2. And then now this limit is infinity over infinity, so you can use L'Hopital's rule or some other method. And if you do that, you'll see that this limit is equal to 2, which is not equal to 0. So the divergence test says this series diverges. In the next example, we have the sum k equals 1 to infinity of 4/3 to the k. So let's again try the divergence test. So the limit as k goes to infinity, a sub k. So again, a sub k is this expression here. So we take the limit as k goes to infinity of 4/3 to the k. Next, k goes to infinity, this gets bigger and bigger and bigger, so this goes to infinity, again, which is not equal to 0. So again, the divergence test says this series diverges. Then finally, we got one last example. So the sum k equals 1 to infinity, 1 over k. So again, this is the terms ak, so we take the limit as k goes to infinity, a sub k would be the limit as k goes to infinity, 1 over k. As k goes to infinity, this gets smaller and smaller, so this limit goes to 0. And so in this case, when the limit is 0, the divergence test is inconclusive. But we'll see later on that this series actually does diverge. Okay, so there's some quick examples of the divergence test. So to check it, you just have to compute a simple limit, and so we see some examples.